All right, let's talk about AI pen test scoping. Right now, a lot of the security testing happening for AI systems just isn't cutting it. You see organizations spinning up these AI red teams, but they're often stuck using old-school pen testing playbooks. And that's a huge problem, because those methods just weren't built for the unique world of AI. So we're going to deconstruct all of this and look at what a real, comprehensive AI pen test scope should actually look like. And this really gets to the heart of the issue. If you're using traditional pen test methods, you are missing a massive chunk of the AI attack surface. We're talking something like 80% of it. That means you're getting a completely skewed picture of your security posture. The risks here are brand new, and honestly, the ways we test for them are still being figured out. We're in uncharted territory. So, let's get into why this is such a big deal. We've got to move beyond traditional pen testing, because AI systems they break all the old rules. They're a completely different beast compared to a standard web app with its neat, predictable endpoints. We absolutely need a new way of thinking, a whole new testing paradigm. Okay, let's put this side by side. Think about a traditional web app pen test. It's deterministic, right? You send a specific input, you expect a specific output. The attack surface is a finite list of endpoints. And we know the vulnerability classes: SQL injection, cross-site scripting, we've seen them a million times. The methodologies are mature. Now look at AI systems. They're non-deterministic. They're probabilistic. The attack surface isn't just a list of endpoints. It's this deep, layered thing we have to unpack. And the vulnerabilities? We're talking about totally new classes of problems like prompt injection and data poisoning that just don't have an equivalent in the old world.
So how do we get our heads around this new layered attack surface? Well, a really useful way to think about it is to break it down into 5 distinct layers. This 5-layer model helps us deconstruct the modern AI system and make sure we're covering the entire stack, from the model all the way down to the metal.
Let's start at the top. Layer 1, the model itself. This is what everyone sees, the part that gets all the attention. But here's the key thing to remember. The model isn't just one single monolithic block. It's actually made up of a bunch of different pieces, and every single one of those pieces could have a weakness an attacker could go after. And when we dig into this layer, you see all these different vectors. What base model are you using? Is it GPT-4, Llama 3, something custom? That choice alone changes your security profile. Then there's fine-tuning and alignment. Like with RLHF, it's super powerful, but you could accidentally break the safety guardrails or even bake a backdoor right into the model. And of course, how you deploy it matters. API, container, on-prem, they all come with their own unique security considerations. Okay, moving down the stack to layer 2, the data pipelines. This is a huge one, and honestly, it's often completely overlooked. AI models are data hungry, right? They're constantly consuming information. And those pipelines feeding them data? That's a massive attack surface. The bottom line is your model is only as secure as the data it's eating.
Think about all the ways this can go wrong. Where is your training data coming from? Could it be poisoned? And what about RAG systems, retrieval augmented generation? Now you've got a whole new set of components to worry about, like vector databases, which have their own vulnerabilities. An attacker could poison the documents your RAG system is pulling from, tricking it into retrieving bad info and spitting out malicious output. We also have to think about live data ingestion points and whether your input sanitization can be bypassed. It's a minefield.
All right, next up is layer 3, application integration. This is where the rubber meets the road, where the AI model actually connects to the rest of your application and the outside world. We're talking about the APIs, the user interfaces, the permission models, all the plumbing that turns a theoretical model into a real, usable product.
And this layer is just packed with potential attack vectors. A huge one is external tool and plugin execution. If your model can run tools, say a code interpreter, what's stopping an attacker from tricking it into running arbitrary shell commands? That's a classic problem in a new wrapper. Another subtle one is exploiting multi-turn conversations. You can slowly condition the model over several prompts, getting it to a state where it bypasses safety checks that would have caught a single, obviously malicious prompt.
Now we get to layer 4, and this is where things get really interesting and kind of scary. Autonomous agents. Once you give an AI the power to not just talk, but to plan, use tools, and take actions on its own, you've opened up a whole new dimension of risk. A vulnerability here isn't just about leaking data anymore. It could lead to direct, real-world impact.
The risks with agents are totally unique. An attacker isn't just trying to jailbreak a prompt. They might try to manipulate the agent's fundamental goals. Or maybe they'll poison its persistent memory to subtly influence its future decisions. And of course, there's privilege escalation. If an agent has permissions to touch the file system or a database, an attacker will absolutely try to exploit that to move laterally. An agent with too much power is a massive, massive threat. And finally, we hit the foundation at layer 5, the infrastructure. This is what everything else is built on. And guess what? All the traditional security problems we've been dealing with for years, in the cloud, in containers, in our CI/CD pipelines, they're all still here and they're just as dangerous as ever. A weakness here can bring the whole AI system crashing down.
You can't forget the basics. Standard infrastructure security is absolutely non-negotiable. A compromised CI/CD pipeline could be used to sneak malicious code into your next model release. A single vulnerable software dependency could be the entry point to owning the whole stack. And things like insecure secret management, that could mean your API keys or even your proprietary model weights end up on the public internet. It's still a critical part of the puzzle.
Okay, so we have this 5-layer model. Now, where do we start with an actual assessment? A great place to begin is with the OWASP Top 10 for large language models. Think of this as the baseline standard. Any good test plan needs to, at a minimum, map its activities back to this list.
This list gives us a really solid framework. It covers the big-ticket items everyone's talking about, like prompt injection, where an attacker hijacks the model's instructions. It also covers excessive agency, which we just talked about, and data poisoning. But here's the crucial part. This is a foundational checklist. It's the start, not the end. It is absolutely not exhaustive.
And that brings us to a really important point, critical scoping blind spots. If you just stick to a baseline standard like the OWASP Top 10, you're gonna miss things. It's a necessary part of your plan, for sure, but it is not sufficient. There are whole domains of risk that it just doesn't fully cover. So, what's missing? First up is the whole area of AI safety. And it's important to understand this is different from AI security. Safety is about things like bias, manipulation, deception, and generating harmful content. Can the model be pushed to violate its own stated values? These are huge legal and reputational risks, and they absolutely need to be part of any serious red teaming scope. Another big blind spot, classic adversarial machine learning attacks. These are attacks that have been around in the ML world for a while, but are just as relevant for LLMs. I'm talking about things like membership inference, where an attacker can figure out if your specific data was used to train the model. Or model stealing, where they can basically reverse engineer your proprietary model just by querying it over and over. These threats have not gone away. And the third blind spot is all about multimodal risks. As soon as your model starts processing more than just text, we're talking images, audio, video, your attack surface just exploded. Why? Because attackers can hide malicious instructions right inside an image or an audio file. It's a clever way to completely bypass safety filters that are only looking at the text. Okay, so we've gone through a lot of theory. We've talked layers, baselines, and blind spots. Now let's get practical. How do you take all of this and actually structure an engagement? How do you build a scope document that's truly robust?
Right off the bat, a scope document for an AI pen test has to be way more detailed than a traditional one. You need a full system architecture diagram showing all the models, the data flows, and where the trust boundaries are. You need an exhaustive list of everything that's in scope. APIs, data stores, the works. And you have to map the OWASP Top 10 and your own custom scenarios to actual concrete test cases. You also got to be clear on the methodology, the rules of engagement, and what the final deliverables will look like.
Here's a good rule of thumb. If your scope document covers less than 60% of that full 5-layer stack we talked about, the model, data, app, agents, and infrastructure, it's simply inadequate. You can't just test the pretty application wrapper or poke at the model's API. Attackers are going to hit you at your weakest link, wherever that is in the stack. Your scope has to reflect that reality. And that leads to one last big thought. A point-in-time pen test gives you a snapshot. But these AI systems, they're changing daily. They're constantly being updated with new data, new plugins, new agent capabilities. That old assessment model just can't keep up. So the real challenge for us in security is this. How do we move away from these one-off tests and adopt a continuous mindset? How do we build a red teaming practice that evolves right alongside the AI it's supposed to be testing?